Hello, everyone, and welcome to this month's Department of Energy Python Exchange. My name is Cameron Riddell, and I will be your host this evening or afternoon or morning, depending on the time zone that you live in. As you all may know, our goal is to have Python thrive within the National Lab System and the associated research sites. And in support of that goal, we are joined today by our guest panelist, Dimo Angelov, who is the Chief Data Science at Thema, where he leads data science research and development of techniques for strategic marketing intelligence. Previously, Dimo was a data scientist and researcher at the Government of Canada developing NLP tools for data exploration. He is currently finishing his PhD in artificial intelligence, specializing in natural language processing. And for today's discussion, Dimo will share with us on Top2Vec, an open source topic modeling project. But before we go into the agenda and introduce all of the fantastic panelists that we have lined up for all of you today, I want to run a few brief points about these exchanges by you all. This call will be recorded, edited, and posted online. That means that we want you all to be conscious of the information that you share, making sure that you're not sharing anything that's privileged or requires any type of clearance. Additionally, as you all know, we are a growing community and we would like to stay in touch with each of you. If you'd like to be kept up to date with our monthly exchanges, then please sign up for our mailing list, which you can find on our website, meetup.doepy.org. You can additionally find recordings of all of our past exchanges on this site, as well as a recording of today's exchange once it has been edited and, of course, posted. For those of you who have never joined us for an exchange, I'd like to share with you that we typically break down these events into 4 parts. First, we're going to introduce our fantastic lineup of host and guest panelists so that you may all get to know them as well as their respective fields and backgrounds. Second, we'll kick off into a coding activity where we'll ask some very applied questions to our panelists to elicit some practical discussion about best practices in software development and where they fit into the world of academic and scientific research. Third, we'll turn things over to our guest panelists who will prepare their shared remarks on Python and, of course, Top2Vec. Then we'll wrap up and have a full discussion about the points brought up by our guest panelists. And for everyone joining us in the audience, this is your chance to ask questions and engage with our panel to help us all understand where Python fits into the life of a researcher. And with that being said, I'll go ahead and share my screen. So behind me, you'll see my screen, and I'll hide in the corner over here so that we can introduce our lineup of panelists. Now, when I do introduce our panelists, we'll share their name and affiliation, and we'll ask the panelists, I should say, what types of questions that they are here to answer. So let's start with our host panelists. I'll kick things off with myself, being a little bit selfish, but hello again, everyone. My name is Cameron Riddell, and while I'm not affiliated with a specific lab, I do have a background in academic research as I studied the cognitive sciences in graduate school. For today's exchange, I would love to discuss any and all questions related to Python as a whole, or specific concepts and uses in Python's vast scientific computing ecosystem relating to tools such as NumPy, Pandas, Polars, and even Matplotlib. Next, let's move on to our next host panelist, and that is James Powell. James, I see that, like myself, you're affiliated with Don't Use This Code, but what is it, James, that you consider yourself an expert in? What are the types of questions you want to answer from our audience today?
So Cameron, you may not know this, but I spent a good portion of my day putting together some notes for a session on dashboarding technologies, and I'd love to share with people when APIs, especially those around dashboarding technologies, are too clever by half. This is a problem that I see in a lot of new Python libraries. People try to use context managers and generators. Come on, folks, let's keep it simple. If you have any questions about, is this a good API or is this too clever by half, I'd love to talk to you.
I think that is a phenomenal topic to have mastery in, James, and I'm sure we'll have plenty of discussion because API design is something that always seems to be wrong, but can always be improved with some thoughtful discussion. Let's go ahead and move to our next panelist, and that is Tanny Chavez. Tanny, I see that you're affiliated with LBNL. Can you share with us a little bit about what you consider yourself an expert in and the types of questions that you're here to help us answer today?
Sure. I have a background in data science, and I am part, as you mentioned, of Lawrence Berkeley National Laboratory, in particular the Advanced Light Source. I would love to answer questions about how to make machine learning or data science solutions more accessible to a larger community.
Fantastic. Well, Tanny, short and sweet, but I know with your ML background, you and Dimo are going to have a lot to talk about today. Next up, we are also joined by Tom Caswell. Tom, I see that you're at BNL. Can you share with us what is it that you're an expert in and the types of questions you want to hear from the audience today?
I'm Tom. I have a background in physics, although these days I mostly do software development, supporting the synchrotron at NSL2 synchrotron at BNL. There, I'm a deputy group lead in the data science and systems integration program, and I'm also the current project lead of Matplotlib. I'm happy to discuss questions about how to do API design for libraries that used to have to be widely used and how to not paint yourself into a corner that you have trouble getting out of.
Well, it sounds like we have plenty of API design experts here. And Tom, with your background, I mean, possibly one of the longest backgrounds in coding in Python here, you are a fantastic person to have on our panel for today. So thank you so much for joining us. We are also joined today by Haran, who is also from BNL. And Haran, can you share with us the same two questions? What is it that you consider yourself an expert in? And what types of questions would you love to answer for the audience today?
So I work closely with beamline scientists at NSLS2 at BNL to ensure that they have a smooth operation. So it's like, so we have this Python-based ecosystem that we use here, and I do a lot of work in the background infrastructure that facilitates the use of Python for science at BNL. So I would allow to answer any question related to that type of thing.
Excellent, Haran. Well, it is a pleasure having you join us today. Let's go ahead and introduce the person of the hour, our guest panelist, and that is Dimo. Dimo, I see that you are the chief data scientist at Thema. Can you share with us what is you're an expert in, as well as the types of questions you'd love to help us answer today?
Yeah, absolutely. Well, I'm definitely very interested in natural language processing. So things like topic modeling, of course, are probably at the top of the list, but that's not the only thing. So I think I'm definitely very interested in have a decent amount of experience in information retrieval. So that could be things like vector search, even wilder things like retrieval augmented generation that people are experimenting with these days. So definitely things around information retrieval, representation learning for NLP, and yeah, I think that's a good flavor. Thanks.
Perfect. Well, Dimo, thank you so much for joining us today. I know that you have a lot prepared to say, especially about Top2Vec, and we're all very excited for that. But before we get into everything related to Top2Vec, we do have a brief coding activity that we play each month at our events. Now, today's coding activity is called When Do I Want? And here are the rules. How we play When Do I Want? How do we explain sophisticated programming concepts to scientists? How do we motivate them to include these in their work? Well, here's how we'll play this game. Our panelists will be presented with maybe an advanced feature of Python that might come up in scientific code. Then our panelists will try to explain why that feature might be desirable in a given piece of code. And finally, our panelists will be scored, not actually, on the specificness with bonus points for relatable anecdotes and experiences working with scientific researchers. So bring up your personal anecdotes on when you should use A versus B, because I feel that some of us have had to make this decision before. But let's go ahead and jump into our first round. And this is the question. When do I want a set or a tuple in Python? And so panel, I will open it up. Whoever feels brave enough. I see James has jumped off audio. So James, do you feel strongly about the set and the tuple here?
Yeah, as a scientific computing developer, put everything into a NumPy ND array, and if it doesn't fit into a NumPy ND array, put it into a pandas series, or actually, we can't actually quite figure out what a pandas series is, put it into a data frame, because when you then go to Hiran or Tom Caswell and ask them to provide some code review for you, they'll basically tear their hair out and have pretty much the worst day of their life.
So James is of the opinion, don't use these built-in containers at all. Why not use NumPy for everything? Is that a fair, any responses to that from our panel?
And I think they're not everything fits in a NumPy array. Trying to do variable length strings in NumPy gets painful quickly, just because NumPy assumes fixed width um, entries and object arrays work, but throw away a majority of the benefits of NumPy. But the actual question, if you want to know what is unique in a group of things, then use a set. But if you care about the order and the order is meaningful, use a tuple.
So we have the set for unique entities, but of course, not necessarily ordered, whereas the tuple does have an ordering to it. Dimo, I see you came off audio for a second there. Did you have something to add?
Well, yeah, the only thing I would add was that recently I started to really like the name tuple. So, if you have, that could just be another thing to add on. But yeah, I think definitely, the set when you want to keep unique things. But if you're going tuple, the name tuple is pretty sweet. I wish it existed for longer than it has.
I'll
Going
add
around,
that
yes.
a set in Python is not hashable. If you want to use that as a dictionary key, tuple is probably better.
So the sets aren't hashable. We do have the frozen set in Python, which is a hashable version of that since it's immutable, although that's a separate distinction. But Dimo, you mentioned the name tuple, and I saw James very eagerly perked his head up because, James, you love the name tuple. Is that correct?
I feel like when you put Python code in front of a scientific computing developer, it's very commonly the case that they're going to want to figure out where's the best bang for my buck. And so if you tell them, write a class or maybe even write a data class, they're going to say, well, that's a lot of code and I just want to do what I want to do. And the thing I like about the name tuple is it is so little code for so much benefit. It's not the best thing in the world. The data class or a frozen data class is sometimes better. Just writing that class out is maybe oftentimes even better. But in terms of one import, one line of code, and then just a little bit in front of each one of those tuples that you have, great bang for the buck, and it's a really good way to introduce your scientific computing developers or scientists to just a tiny amount of object orientation, a tiny amount of data structuring, without making them go overboard with all of the different underscore methods.
Absolutely. I think that's a fantastic extension to add to your code. So if you're just using tuples for any data structuring, reach for the name tuple, reach for the data class. Python has all of these more modern implementations. Dimo, did you have something to add there?
Well, I was just going to say, I don't want to jump into Top2Vec, but when I did implement it, which was about 4 years ago, I guess I wasn't as familiar with this at the time and not even sure if a name tuple existed then. Maybe it did, but all the return types of Top2Vec are often tuples. And it would be really nice if they were name tuples, because then you'd be able to kind of make sense of the various different things that it returns. So something on my to-do list that I've been meaning to get around to.
Yeah, I actually see that a lot in stats models. If you're familiar with stats models, they do use the name tuple return type, which I will say, as when I was first learning or navigating that library, I was a little confused about it. And then once you understand the name tuple pattern, it becomes very helpful, very concise, especially if you're only interested in maybe a single field out of that name tuple. Like for stats models, right? I might be interested in just the test statistic or just the p-value. I can just grab that result type and then do .p-value. Very, very intuitive. All right. Any final thoughts for the set versus the tuple? They're quite different. I wish we had one more round on the list versus the tuple, but we'll jump into something else next. If there are no final thoughts, let's move on to our second round here. When do I want to use NumPy versus Xarray? And so I'll open that up to the panel. So if you're the first to respond and you're familiar with both these tools, please do feel free to describe these tools to us. James, I see you've come off audio.
I think Xarray is kind of a marriage of pandas and NumPy, with a lot of functionality that the NumPy core developers keep saying they'll eventually add to NumPy, but NumPy's development speed isn't at the same as other projects. Basically, we've got some n-dimensional data, actual real n-dimensional data like an image, a surface, a volume, and we want to label the axes with the coordinate system. We've taken an image on a detector, and we don't want to say, here's position in memory 0, position in memory 1, position in memory 2. We want to say, here's 0 inches from the center, here's 1 inch from the center, or 2 inches from the center, or maybe even centimeters, whatever units we want to use. And we want to do operations with the knowledge of that physical coordinate system or other coordinate system.
I don't think it's too far to go and say that X-array is effectively NumPy, but with a named dimensional coordinate system. So instead of having your code NumPy and D-array, square bracket 0, square bracket 1 through 10, instead of that first square bracket 0, you can select your dimension by name, which is incredibly useful. Is there any other reasoning or times where we would want to use NumPy versus X-array?
I have a controversial idea, though. And this, I think a lot of people may agree, some people will disagree. All of us have taken some scientific computing code that operated on matrices or higher n-dimensional structures, and we said, hey, we keep doing the same thing over and over in our code, why don't we write a function? And then we publish that function in a library. Our end users come to us and say, oh, you know what? I have the exact same problem you have. I want to use your function, but my axes are structured differently. You have width, height, but I have height, width. And are you going to tell them, okay, reorder your structure, which requires a memory copy and all of those? Or do you have your function take like the axis on which it operates, where that becomes really complicated because then you have to, pass in like tuples of 0, 1, and 2 or whatever. Or maybe you can tell them, give me an X-array where the axes are named, where the dimensions are named, and I'll just operate on the named thing that's called height, and I just assume something there. The upside is you can have code that's a lot more readable, and you can make your users a lot happier because they just have to name things a certain way. Downside is they do have to name things a certain way. They do have to have this extra dependency. The upside of that is X-array is a pure Python dependency, so maybe adding that into the project is not such a big deal. But the downside is they have to be aware of something else that maybe they weren't aware of already.
I do think the pro of you get to avoid, when you're aligning two ND arrays, of avoiding that square bracket np.new axis or none to add artificial dimensions there is a big plus in the readability of your code. So is that the end of the story? Is X-array just better than NumPy? I will say one drawback might be sometimes the X-array data structures take a little bit of time to set up. So if you are looking for just pure speed, ensuring that your ND arrays are going to be aligned before your operation can save you a little bit of the overhead. But in terms of readability, X-array is a leap and bound above NumPy, in my opinion.
If you want, oh, go ahead, Tom.
So X-ray also provides levels of nesting above a single array. So you can have a data set which contains multiple arrays which may or may not contain shared coordinates.
Yes.
That is can be extremely useful for carrying around complex data sets.
Yeah. And Tom, I believe, correct me if I'm wrong, but the kind of standard example are the netcdf files, right? So especially for weather data, where you have lat, long, and time, and then you have like a precipitation in time. Now, precipitation doesn't have the same lat long coordinates, but they're both aligned along that time dimension. And that's the X-ray data set you're describing there, correct, Tom?
Correct.
Fantastic. So not just multi-dimensional, but multifaceted data sets as well. All right, well, I think that's a thorough discussion of our NumPy and X-array counterpart. Let's move into round 3. Going back into the pure Python world, when do I want to write a function? Any thoughts from our panel?
Well, I guess a quick one is like, if you're writing something 2 to 3 times the same thing over again, it's probably time to think about turning it into a function and standardizing so you don't have to keep rewriting that piece of code.
Saving yourself some lines of copy and paste. That's fair. Tanny, I saw you came off audio. Did you have another point to add?
Yeah, I had a similar thought as well. And in addition to that as well, I think very recently we have been exploring as well, breaking down our code a bit more thoroughly so that then we can start adding some decorators into some of these functions so that we can keep track of different things. So like we bring in, I think, an easier way for us to track maybe, for example, timings on like how long these functions take, especially very powerful if you would like just to add like a single line of code so that we can add these timings everywhere in our project. So in that case, it just brings up a little bit more capabilities for not only executing our code, but also keep track of things on timings or any other tracking methodology.
So a little bit of the abstraction or refactoring gives you composable units that you can then do some meta features with. I think that's a fair point. There's also our profile hooks as well and sys, but I think the refactoring to functions will help us with that. But Tom, I see you came off audio as well.
I think that the APIs in libraries tend to be very general and tuned to a use case that is not exactly yours. And if you're finding that an API has a little bit of friction for you, it can be very valuable to write a function that either changes the defaults, which again you could do with like functools.partial, or changes the way the inputs are parameterized. A canonical example is if you want to specify a grid, you can specify the start, the stop, and the number of steps, or the start, the number of steps, and the step size, or basically pick any of those and you can make it work that way. So if the library authors have made a choice that you find unintuitive for your use case, write a function that translates the way you want to spell it to the way they want to spell it, and then never worry about the library's way in your day-to-day usage.
I think that's a great point, Tom. I was just working on a piece of code and I had two options to make that convenience layer that you were just describing, right? Do I inherit from a class? So do I subclass the object that I'm just trying to add defaults on top of? Or do I just write a helper function that then returns to you an instantiated version of that class with some defaults defined, and you can just override those in the function capacity? Now, as I was thinking about this, I was also trying to keep in mind the end users, the people who are going to be interacting with this thing. And I figured that for that audience, it would make much more sense if I had a function that returns a pre-configured version of this class, rather than going through inheritance, which might confuse them, because now there's a brand new object that they have to interact with. So I think functions for providing defaults is a fantastic point there. James, did you have any additional thoughts there?
I'll let you chime in, Cameron, with the distinction between intentional and coincidental repetition. Instead, I think that when you're designing APIs, one of the stops along the way of designing these APIs is the bag of function style API, kind of like NumPy, where everything's just a function that takes different data arguments, and it works, and it's pretty easy for people to learn, and it's very simplistic. Another step along the way is the matplotlib.pyplot style API, where it's a bag of functions plus some missing hidden state. Another step along the way is let's actually take that state and put it in a class somewhere. And then very far down the path, maybe going a little bit too far, is the let's do things with context managers and generator coroutines and all of the object model. Somewhere between the absolutely most simplistic API, something that you see in something like NumPy, SciPy, or Matplotlib PyPlot, and the really bizarre approaches that we saw in, say, PyMC4, PyMC3, and PyMC, there's a nice sweet spot where it kind of looks like everything else that you use. And between you and me, I think some tools like Pandas are kind of in a nice part of that sweet spot, despite the inconsistency of the API. I think Pandas actually has a very good balance between not going too far, but still not just being a big bag of function.
I agree. Useful data abstractions, hopefully, as long as they serve their purpose, will always be useful. But James, you mentioned another point about the intentionality of what we are trying to put into our function, right? That's the intentional repetition versus unintentional repetition. And the idea there is that if I'm writing some code and it looks like I've copy and pasted the same thing maybe 3 times, I want to make sure that that repetition is incidental, or is intentional, I should say. If it is intentional, then that's a prime candidate for refactoring into a function. If it's non-intentional repetition, meaning at any point in my code, I could say, oh, I want to rerun this, but I'm going to change the second copy paste just slightly. When you get into that loop, and this is a lot of the code that I write for Matplotlib, creating very high quality data visualizations, I want to leave everything as exposed as possible, because I never know if I'm going to give a client a figure and they're going to say, oh, can we move that title, just 8 pixels to the right? And if I had written a function that set, text properties on the title as well as many other labels all at the same time, I'm going to have to go into that function and say, if, text is title, then do something special. And when you get into that do something special every single time, well, that refactoring is not saving you time. It's in fact costing you time at that point. So that's the point on the intentionality of the repetition. But any final thoughts on when we should write a function here? If not, we have a natural lead into our fourth and what will be our final round here. And that is, when do I want to write a decorator? And so I'll open this one up to the panel. When do I want to write a decorator, or when do I want to use a decorator? And I don't think that from data classes import data class is a very valid answer for when you want to use one, because we've already talked about that.
I think in terms of using a decorator, if you're in a framework that's in using them, then you want to use them. For instance, a lot of the web APIs like Fast API and Flask handle a lot of the boilerplate of hooking the Python functions you're going to hook up to the HTTP endpoints via decorators.
Yeah, so there's a lot of APIs built around the use of decorators. And of course, if you're using an API, you'll want to play within their sandbox as much as they've allowed you to. Tom, do you have another thing to add there?
So in terms of when you want to write one, I mean, that probably is when either you have a significant amount of boilerplate that you need to put around every function. For instance, Danny mentioned earlier, adding timing. So like having a decorator that you can put on a function that will log the start and stop times of that function is a really good use of it, because that way the textual impact on your code of adding or removing is very small, but the functional impact can be quite large. And the second case would be if you are again, if you're writing one of those APIs where you need your users to provide functions to you, it's much nicer to write a decorator than it is to say, well, write your function and then instantiate one of my objects, then call a register method on it. That's just a lot of like places where they have to type the same thing multiple times.
Yeah, absolutely agreed with you, Tom. Now I saw Tanny come off audio. Tanny, did you have another thing to share on top of that?
That I think resonates a lot with what I was meaning to mention as well. I think I completely agree with Tom on this regard. I think just to build up a bit more on the use of APIs as well as decorators, I wanted to throw out there that another one that also, it makes a lot of sense that this one also allows us to use decorators is dash plotly when developing web user interfaces. That one also makes use of decorators in order to perform or to elaborate on callbacks and how to interact basically with different components in a web UI. So I also do see them as a very helpful framework in case, for example, if we were to be putting together a framework that will be later used by users, and we would like for them to be able to repurpose some few functions that per se will not be receiving a lot of parameters. Perhaps in that case, we can put together some few decorators for them. But I completely resonate with Tom's comments before. Just wanted to throw out there that Dash Plotly also is another framework that makes use of callbacks and decorators in general.
And James, did you have something to add there as well?
I'll offer maybe novel thought here, which is oftentimes we think that the APIs and the frameworks we build have to be for the purpose of accomplishing the actual end user goal, the business task you're trying to do. But Python has a very rich runtime, which means it has very rich reflection capabilities, which means you can write Python code that is about the code that you're writing. In other words, one thing that I think is actually a very interesting idea is write more decorators, write more context managers, use some of these esoteric features, but not for end use case problems. Instead, for you to help manage your code. For example, it's almost certain you have a couple of functions in your library. And maybe you need to put a to-do to remember to go update them, refactor them. You could put a comment in that code, all caps to-do. Why not write a decorator and have that decorator register the function? And then if you run your script under a certain modality, it can go discover all the functions, use the inspect module to tell you the lines of code where they are, maybe even automatically submit Jira tasks for you, or maybe update Jira tasks to let you know those haven't been updated. Now, the interesting thing there is that kind of code doesn't actually really have to work that well. And you can try some obscure API things because largely the risk of it not working is, the end user's code still works, but These can maybe help you with the development process, maybe help you with that. And there's always some human in the loop there.
Now, Tom, I saw you come off audio for a second. Did you have something you wanted to add to James's comment?
I was going to say git grep works real well.
Very fair point for maybe the to-do item, but also, James, I know you've talked about the dirty hack decorator. Could be a very appropriate use case of that as well. Now, one final thought here. When talking about decorators, I always find it useful to talk about the points in the code where we can actually hook into using a decorator. And if we are decorating a function just like we have here, you can actually execute some Python code when the decorated function is defined. That's what our things like FastAPI, Flask, Plotly are all doing. They're taking the function that they're decorating and they're registering it to some endpoint. Now, additionally, if that decorator returns a wrapped function, well, then you can also hook into anytime that this function is called before call site or as soon as that function returns. So you can do something before or after the execution of that function call. And those are the three common hook points that we'll use anytime you see a decorator on a function specifically. Well, if all of our thoughts are out there, then I think we have done a fantastic job about defining when we should write one and when we should use one. And this concludes our coding activity for today. Thank you all for joining us in that coding activity. Now, for the time of the hour demo, I will turn things over to you so that you can go ahead, share your screen, do what it is that you need to do, and tell us about Top2Vec.
Okay, everything's clear. Excellent. Well, without further ado, I'll present to you Top2Vec, which is both a Python package and a topic modeling algorithm. I'm going to start off with a little bit of the motivation behind the algorithm, talk about that, and then I'll move more into talking about the package and kind of the second half. So first question, why do we need topic modeling? Why do we care about this? Why is it relevant? Well, 403 million terabytes of data are created each day. It's a good amount of data. And with headlines such as, why, yes, there is such a thing as too much data and why you should care. And can too much data drive businesses to their deathbed? It's clear that we've kind of rapidly gone from big data to too much data, not unless you're an LLM company looking to mine the entire internet and train large models. But for most other kind of instances, that is the case. So how does topic modeling help with this problem? Well, if you have a giant pile of data and you want to make sense of it, for this talk, I'm going to focus more on text data, but you could really expand this idea to other types of data. But if you have text data, giant pile of it, and you want to make sense of it, well, topic modeling helps us at the very least by sorting it into piles and giving us perhaps kind of labels for those piles that essentially help us to start introspecting what our data is. So the Yahoo Answers data set. So this is going to be just a practical jumping into something tangible to think about. What is this data set? Well, it's data from Yahoo, and these are questions that people have asked in Yahoo and have been answered. And there are 50,000 posts that have been manually kind of categorized by people. So these are human sorted piles of posts, and they're on 10 different topics, such as science and math, computers and the internet, sports, etc. The one I want you to remember is computers and the internet. So the example I want to jump into is like, what if we had these 50,000 posts, but we didn't want to have people go and manually label them? What if we wanted to somehow programmatically kind of categorize these 50,000 posts? We know they're from Yahoo, but we don't know what they're really about. So if I just showed you a 2D representation of the vectors of these 50,000 posts, this is what they look like. And you would probably say to me, that's not very informative. So if you ran this through Top2Vec and got it to label the topics that are here, we would get the following. And now if you remember, I asked you to remember the computers and internet topic. Well, we can see here on the very right, one called computer troubleshooting and virus removal. So that is in fact the topic discovered by the topic modeling algorithm. And it kind of makes sense because what are people asking about on the internet about computers? Well, the various different ways in which they've managed to make a mess of their computer. So this is one thing the topic modeling gives us, right? These are the piles. Now, we might want to ask, okay, but what specifically about computers are we troubleshooting here? And we can see kind of these are some of the most relevant posts in the topic. So this one's talking about, your hard drive being full, antivirus scans. This other post is talking about downloading Mozilla Firefox Explorer because apparently it's faster. So that's great. We can get piles. We can figure out what the actual content from the piles is. But these are 10 topics. Is that too granular, or rather not granular enough? Well, we can zoom in and actually get as much granularity as we want with topic modeling, right? So we can see here, this computer topic is actually composed of all sorts of things like reformatting and reinstalling Windows operating systems, choosing a programming language, setting up and troubleshooting wireless internet connections. So you could, again, introspect every one of these topics and see kind of what that relevant content is. Now, before continuing, I do want to do a shout out to DataMapPlot, which is the library I use to generate these beautiful diagrams. You can find it on the GitHub of the Tut Institute, and I'll be referencing a few of their other libraries that are used as part of Top2Vec. And again, I highly recommend you check out their GitHub. So what do we want out of topic modeling? Well, we want it to be able to sort our data into topics. We want it to be able to label those topics. We want to be able to find the most relevant content for each topic so we can explore our data efficiently. And we probably want a hierarchy of topics because there's not really one optimal granularity. We want to be able to see multi-resolution depending on what granularity we're interested in. So I'm briefly going to go over traditional topic modeling just to give you the motivation behind Top2Vec. It's going to be rapid fire, but essentially LDA is kind of one of the most popular traditional topic modeling algorithms. It's a generative probabilistic model. A document is a mixture of topics, and a topic is a mixture of words. This is how LDA sees the world. So on the left here is an example of what LDA topics would look like. So they'd be a distribution over the vocabulary. And so you could see for each word, there's an associated probability. On the right-hand side is a diagram that's actually giving too much credit to what LDA does, because it doesn't actually tell you where the topics are in a document. And the reason it doesn't do that is because LDA treats document as a bag of words. And what is this representation? Well, it's literally just a vector of the entire vocabulary and a count of the words in each document. So in this puppy example here, we can see puppy shows up once in this piece of text, and so it has a value of 1 in the bag of words vector. So it's a very simplistic representation of documents. It's still nonetheless quite powerful, but there are limitations, and those are the word order is ignored. So we're kind of losing a lot of syntax information. Words are independent, so we're ignoring semantics. So the word dog and dogs will be treated as different words. And lastly, topic in LDA is a probability distribution over the vocabulary. So if I asked you which is a better topic, the, and, such, they, many, were, or topic, model, documents, text, you would hopefully think that the second topic is better than the first one, or at least it's easier to make sense of. And so what makes a good topic is how informative it is. And the problem with LDA is that it really just treats topics as distributions over vocabulary. And now if you can imagine our use of words, words like the and such are the most probable words. And so that creates a problem for us with LDA, where we have to then filter out those words to be able to make sense of our topics. So the overall motivation behind creating this algorithm was that bag of words representations of text ignore syntax and semantics. With methods like LDA and other probabilistic generative methods, uninformative words are the most probable in topics. And so we have to do various types of things to clean those out before we can make sense of them. And then a point I hadn't mentioned, which is that with these algorithms, you also need to specify the number of topics for them to work. And we don't always necessarily know the number of topics that are present in whatever data set we're looking at. So what is a Top2Vec algorithm? It's actually quite basic and quite simple. It has several stages, but the first one is creating a vector representation of our text. The next one is finding dense areas of those in the vector space, because the assumption is if there are a lot of things that are close together, they probably have something in common. From those dense areas, we calculate topic vectors. We then label the topics. And lastly, we assign documents to a topic. So we'll more slowly go through each point. But first step, we want to create this joint document and word semantic embedding. We can do this with a neural network. We could do this with a Top2Vec model. There's various different ways you might be able to do this, but the aim is to have a vector space where semantic distance is meaningful. And so we can see in the top left here, the purple points are documents, and we can see they're more about AI, and the green points there are vocabulary. Similarly, they kind of represent that. And on the bottom right, we have more kind of probability and math related topics, or rather documents and words. So once we create this joint embedding, the next thing we want to do is create a low dimensional embedding of it. And why do we want to do that? Well, because finding density in a high dimensional space is both very expensive and problematic due to the sparsity in high dimensional space. And we're going to do this with an algorithm called UMAP, which I highly recommend if you're ever looking at doing dimensionality reduction. It is also available at the Tut Institute GitHub. So once we find this low dimensional embedding of our documents, we then use HDB scan to find the dense areas. And why are we looking for these dense areas? Well, because the assumption is every one of these dense areas is an underlying topic in our data set. Again, HDB scan is available through the GitHub of the Tut Institute. So once we get these dense areas, then we get to the key point and the key assumption of the algorithm, which is, I would say, often underappreciated, but it's the calculation of this topic vector. So this topic vector is just the centroid of the dense area. And the important thing about the topic vector is that because it's central to all these documents, it is also in some way the closest to all of them. And therefore, the nearest documents to that topic vector or vocabulary are the most representative of that area. And so once we calculate these topic vectors for each dense area, we then look at the nearby vocabulary, and that's how we create the kind of topic description. Now, this can be done in several different other ways. Another way you might do this is you might say, well, I'm going to look at the nearest documents to this topic vector because those are kind of the most representative of that cluster. Or in today's, LLM world, you might say, well, I'm going to take the top 5 or top N documents nearest to the topic vector, and I'm going to get the LLM to tell me what the topic is. But the key point here is the topic vector allows you to find kind of the most relevant things to, or most representative rather, things to a cluster. Now, I showed you this picture here, and so HDB scan finds the initial amount of clusters and therefore topics. But what if we want just 10 topics, like I showed you in that initial diagram? Well, the way we get those is through hierarchical topic reduction. How is that performed? Well, to calculate the topic sizes, that's our kind of step 1. So we said we have these topic vectors. Well, the way we're going to first calculate topic sizes is we're just going to assign every document to their nearest topic vector. Easy. And then what we do is until we reach the desired number of topics, we're going to find the smallest topic. We're going to look at where the nearest topic is. We're going to assign it to that topic, and we're going to adjust the centroid. So this hierarchical topic reduction just aims to preserve kind of the most prominent topics without, yeah, that's really what it's aiming to do. So with all that said, back to this diagram of the 10 topics, I briefly want to just run through the actual code and what it looks like to generate something like this. So this is the code that is required to generate this diagram, including the topic modeling and the diagram generation. So at the top, we can see we're importing UMAP. This is for dimensionality reduction. Then we're importing Top2Vec. Then we're importing data matplot for the pretty pictures. And then we're importing sentence transformers because that's what I chose to use as an embedding model. So we load our data. So Top2Vec has several different embedding models you can use. You can just use by string name, but you can just really use any model you want. You just have to kind of create a function and then pass that function to Top2Vec, and it'll use that for the embedding. So the first thing we're doing is we're specifying this MPNet as our embedding model. We're then passing to Top2Vec our data, which is just a list of strings. And then we're setting n-gram vocab to true, which gives us phrases for labels. And then we're passing it the embedding model. That will then generate an initial set of topics. And like I said, we wanted to perform this hierarchical topic reduction. So we just call that, and then we're left with just 10 topics. We can then get our labels from Top2Vec. And then we can take the document vectors from Top2Vec, give those to UMAP. It'll generate 2D vectors of those. And then all we have to do is pass these 2D vectors and the topic labels to data matplot, and it'll generate this beautiful diagram. So that's kind of a brief lightning overview of the motivations behind Top2Vec and a brief use kind of example of how to use it. It's got a lot more uses. You can pivot easily from documents to topics, from topics to documents. You can play various sorts of games like that. It does have an API guide on the read the docs, which is fairly well documented. So you should be able to find what you need there if you find Top2Vec interesting or useful to your workflow. So a brief history of Top2Vec and the actual project. So it really kicked off at actually a conference at the Tut Institute, and a lot of the ideas were born there and first lived in various notebooks scattered in all various forms of spaghetti code. And those were kind of the foundation of Top2Vec. And then through many months after the conference, it evolved, but it sadly continued to live in notebooks, which were, as you can imagine, very hard to share, very difficult to collaborate with other people on it. And obviously it was not the right format for this algorithm. I was encouraged by my colleagues to, put it on GitHub and write a paper about it. And I always meant to do it, but could never find the time. And then sure enough, COVID came along and I had a lot of spare time. So during that time, I was able to port over the code onto GitHub, clean it up, write a paper describing the algorithm. Once I got it on GitHub, I realized, you want to make this much easier to use. You want to document it. So then I created a Python package so that you can just pip install it, created API docs so that it's easy to use. And yeah, and now it's on GitHub and you can easily create it. And so once I did that, I figured, maybe I'll share this. I read R machine learning quite a bit. So I thought, maybe somebody else might find this useful. Little did I know, it quickly took off and kind of quite a lot of people found it useful. And I was very happy to see this because I'd put a lot of work into it and it seemed that a lot of other people were getting uses out of it. So I was very happy to see that. Currently, it gets about 13,000 downloads a month, which I think is quite a lot. I'm, again, quite surprised of how many people use it. And again, I'm very happy. And I would say that I probably need to give the repo a little bit of love, but between working and doing the PhD, I'm a little bit short on time. And as you can imagine, there's quite a lot of things to maintain, but I'm working on some quite interesting things that are coming soon. So the open source community is very interesting. So out of Top2Vec, a few other things came about. So I guess the first one to come about after Top2Vec was BirdTopic, which essentially, took most of the Top2Vec code and swapped out the final labeling layer. So instead of using these topic vectors and adjoint embedded labels, instead what it did was it uses something called class TF-IDF. So it essentially for each cluster, each topic cluster, it creates a single document and then uses TF-IDF to find different, to kind of find the prominent words to label the topics with, which is quite interesting because in fact, during the workshop I mentioned, the first version of Top2Vec actually did exactly that until I discovered the ability to kind of pivot from a topic vector to nearby words. So it's quite interesting that somebody else arrived at a similar conclusion. There's pros and there's cons to both algorithms. I think I'm biased, of course. I think there's a lot of times where I think Top2Vec would probably be the right thing to do. But I think that always the right thing with these things is to try both and see what works best for your use case because every use case is unique. Another key thing to point out as a distinction is BirdTopic will label anywhere between 5 to 20% of your data as noise, depending on the kind of what HTTP scan returns, which might be correct in some cases where you're looking for very salient data. But if you know that you want to label all of your data with topics, then perhaps BirdTopic is not the right choice. Another interesting one that came about was something called buzzwords. If you're familiar with or not familiar with, Bumble is a dating app, and basically they wanted to categorize their very many users and kind of their interests. And so they took a combination of Top2Vec and BirdTopic. And really their aim with buzzwords was to make it really fast and scalable. I think at this time, Top2Vec didn't have GPU support. And so I think that was, again, it's very cool to see that people can just take code, reuse it, do what they want with it. I think that's the beauty of the open source world. Nonetheless, I think all the algorithms now, all three of these are GPU supported. They're all very fast. And again, I think it's always best to just try them out and see what works best for you. It was very cool to see that somebody also created an R version of Top2Vec. So once again, it's just, this is the power of the open source community. People are trying to spread what they find useful and make it available to others. So, you know, I'm really grateful for all the people that put their time into supporting algorithms. And so in summary, what is Top2Vec? Well, it automatically finds the number of topics, gives you coherent topic labels. You can use any embedding model. It gives you hierarchical topics, and you can just pip install it, and it should be quite easy to use if you're ever in need of a topic modeling algorithm. And that's the end of the presentation.
Thank you so much, Dimo. Now, for everyone in our audience, this is your chance. Please use the Q&A widget if you have any questions. I'll also invite back up our team of host panelists to ask any questions to Dimo. But before we get some from our host panelists, I will say we do have one question in the Q&A. And this is more generalized, just around, I'm going to use AI, but I know that's not the right term here. But in a general sense, how has the extreme popularity and hype around the large language models affected these more, quote, classical approaches?
You mean with regards to topic modeling, I'm assuming is the
I
question.
believe so, yeah.
I would
You know,
say,
could I feed ChatGPT just a bunch of data and say, what are the topics in here? And
Yes,
expect
that's a
something
great question.
reasonable to come back out?
That's a great question. So there's two answers to this. So the first one is, you know, if you have 1,000 things you want to get the topic of, then yeah, I think ChatGPT will do a great job of giving you the topic. One slight problem there is that it's going to have a variation with the topic it gives you. So it might be finance and business, business and finance, finance and businesses. So you're going to then have to find a way to standardize those labels. But you know, that's not a huge problem. Now, if you want to do 1 million of these things, it can get expensive. It can become time consuming. And maybe for small volumes, I think, you know, if you have 5 things, yeah, just ask an LLM what the topic is. But if you want to do this at scale, probably not. Now, one thing I'll say that the LLMs have solved is the labeling issue. So for a very long time, the biggest pain point in topic modeling has been, you know, how do you label this topic? You know, often you have a great ability to figure out what the common sections of a document are, or the comment or the clusters of documents are, but you have not a great way of labeling them. So I think that's the great thing that's come out of the LLMs for topic modeling. And like I kind of mentioned in the talk, one of the great things of using Top2Vec is when you go to your topic vector and you look at the nearest things, you can find a representative sample of your cluster that is good for sending off to an LLM to label that topic, rather than sending it the entire cluster. So yeah, I hope that somewhat answers the question.
Yeah, that makes a lot of sense, right? LLMs are a hammer, but when you need to drill in, you know, 1 million screws, you should reach for a power drill instead of a hammer. Sure, it'll get it done, but like you said, Dimo, it's going to be more expensive and probably slower.
Yeah.
Now, the topic labeling is interesting to me. Was that previously just done by hand, maybe MTurk workers or something like that?
Yeah, that's an interesting question. I mean, for many use cases, definitely manual labeling, but yeah, I think that the main motivation behind Top2Vec really was that when you would run something like LDA or other traditional topic modeling algorithms, there's a lot of, you have to stare at it and tune knobs and do various types of things until the topics are somewhat readable. So I think it was before just more a game of playing with parameters.
Is there any good way, or I should say automated way, of kind of exploring parameters there? Or the parameters that you would input or tweak onto a model?
Definitely. There's people use various types of coherence scores and as a proxy to explore the search space of other variables. But my recommendation would be to use something like Top2Vec, which automatically gets you, you know, labels that are readable right off the bat. That will be my recommendation.
Very fair, very fair. Now, I do have a follow-up question, but I want to make sure that our host panelists also have some time to ask questions if they have them. If not, I can follow up. But Tanny or Huron, any questions for Dimo?
Yeah, I actually had a question, more related. Well, first of all, very nice presentation. And I'm mostly curious about if there are any limitations in terms of what type of embedding models can be used for under this framework. Like, is it compatible with multiple different like ML frameworks like PyTorch, TensorFlow, maybe others? Are there any limitations in what type of embedding models we can use?
That's a great question. So, I mean, the way it's currently designed is that you can just pass it a function that's your embed function. And so whatever model you have in there, it's completely agnostic. So you should be able to use any model. And, you know, if there are issues, feel free to reach out. But yeah, the aim there was, you know, initially I tried to kind of handpick models that I think work well so that there's minimal issues when running it. But then eventually I realized, you know, you just have to be able to plug in whatever model you want, because there's too many of them, and you know, it's up, everyone knows what's best for their use case.
Thank you. No, that makes a lot of sense. And I think the other question as well that I had, and I don't know, maybe like this is maybe something in your mind already. I was wondering if some human labeling in collaboration or like in support as well with the automatically detected labels could also maybe enhance the results, kind of like as a fine-tune process of the detection of the topics. I was wondering if you have any thoughts, you know, like with regards to like human labels versus the detection of automatic labels just based on the position of the feature vectors.
For sure. No, that's a great question. So at one point we worked with a lab that was basically taking some kind of survey results, and they had, you know, I think several thousand of them, or maybe several tens of thousands of them. And then they, in this lab, would manually label all of them. And obviously that's a very painstaking process. And one of the things they wanted to do was see if we could help them to not automate the labeling, right? But help augment their ability to label. And so what we would do is we would find the granular, so like they would tell us, you know, we want to sort this into 10 topics or 20 topics. We'd run the topic modeling algorithm, and then we would hand that to them. And so it's a pre-sort, and then they could, first of all, change the label of each one of those topics. They could remove, like they could, so like the one interesting thing here is that for each topic, you have almost a score. So you'll know what are the things that we're least sure about belong in a topic. So they could then go straight to those and see, oh, maybe this one should go in this other topic. And so it definitely helped with the manual labeling by giving them the ability to have scores, confidence scores for each topic, as well as pre-assigned labels that they can then change into whatever they think is actually more appropriate.
That makes sense. Thank you.
I love that goal. I do a lot of work with open science demo. So hearing that we can create automation for these things. And I love automation, especially when it gives you, right, the same outputs. If you give it the same inputs, fantastic. But oftentimes, right, we do need that human intervention. So being able, the work that you did with that lab sounds incredible, because you gave them a way to track, you know, what changes they made to the automatic labeling and why.
Exactly.
So it's
Yeah.
fantastic to hear. I do have one final question. That's the Top2Vec R. How
Yes.
do you go about managing, right, features and things for the R version versus the Python version? Or do they live kind of separate from one another? And if one develops a really cool feature, then the other will try and pick it up.
Yeah, to the best of my knowledge, the R1 definitely doesn't have all the features. It's just like the core algorithm. And I believe it's with just actually a Doc2Vec embedding, because that was kind of the initial Top2Vec. I don't think that they've added all. Yes, they're completely disconnected. I think the point there was just to highlight that, you know, when a community needs something, it's just cool how they just bring it in, they port it over, and just think it's a great example of the open source community kind of doing its thing.
Yeah, it is fantastic, just making it more accessible to everyone who needs to use it or can use it by making it cross-language. And I do appreciate that effort. Like I said, a lot of open science work and open source is just right there with everything.
Yeah.
Awesome. Well, we are just at the top of the hour, so let's go ahead and wrap up. This has been such a phenomenal exchange, and I want to extend a huge thank you to Dimo, our guest panelist, and a thank you to our audience for joining us this month. If you are not already signed up for a newsletter, do make sure that you subscribe. The subscription link can be found on our website, that is meetup.doepy.org. Or if you don't like receiving just one email a month, do make sure you keep a regular eye on that website for information on our upcoming exchange next month. We'll be joined by Kyle Chard from A&L and the Parcel project for parallel processing pipelines in Python. It's a lot of alliteration right there, but thank you all again for joining, and I hope to see you all next time.